Welcome back, and we're going to press on with our study of convergence of infinite series. So now we're going to look at a series where each term we take the absolute value, because we've so far seen that having a positive sequence or positive values of a sequence is really important to our conclusion of whether a series is convergent or not. So when we look at the series of the absolute values of the sequence terms, we would say that, and if that ends up converging, that sequence, or that series of absolute value terms from a sequence, if that ends up converging, then we say that the series is absolutely convergent. Okay, and so the series of So be careful with the language here. I'm even getting a little tongue-tied. So when we would say that the series without the absolute values would be absolutely convergent, whereas if we looked at the series of the absolute value of the sequence, we would say that series is convergent. So absolutely convergent do not include the absolute value signs. Okay. Also, just know that this isn't these things don't go hand in hand. So if we have that a series is absolutely convergent, we don't actually know if the series is convergent without the absolute values. Okay, so just be aware of that. Okay, so we want to look at each of these examples here. So if we could imagine, okay, here's our entire sequence, right? So if we look at the absolute value of that, so if we call this an, if we look at the absolute value of an, that would be the absolute value of -1 to the n plus 1, all over n to the fourth, right? Absolute value of this is just 1 over n to the fourth, and we know this as a series, 1 over n to the fourth, converges by p series. So that means that the sequence an is absolutely convergent. Okay, now this one does have a nice bonus. We can actually say, and the series an is convergent, but to do that, we'd have to use the alternating series test. Okay, so you can show that on your own time. Okay, but that's kind of an add-on. Okay, so again, we're only looking at we can only say that with absolute convergence, we would look at the absolute value of the sequence and say, is the absolute value of that sequence, when we put that in series form, is that convergent or not? Okay, now similarly for this next one, we would say, okay, well, if this is all, let's call this bn, just for something different. So if we look at the absolute value of bn, right, that's going to be 1 over n to the 1/4, right? And if we look at the associated series of that, 1 over n to the minus 1/4, or to the 1/4 rather, is divergent by p series. So this one is not, so series bn is not absolutely convergent. But series bn is convergent. Again, you can show this by alternating series test. Okay, and so we can have cases where it can be convergent, but not absolutely. It can be absolutely convergent on its own as well. Does that necessarily imply that it is convergent? Well, we'll get to that in just a moment. This last series that we dealt with, the bn, that is an example of a series that we would call conditionally convergent, because the sequence on its own converges, but it's not absolutely convergent. Okay, so, or I should say the series converges without absolute values, but it is not absolutely convergent. Now, I mentioned a question about if a series is absolutely convergent, is it necessarily convergent? And yeah, it actually ends up being true. So if we have absolute convergence, then you're guaranteed to be convergent. Notice that it is one direction only. So it is that if you have absolutely convergent, then you can go and say it's convergent, but it is not true the other way around. And in fact, we have a counterexample to that above here. Okay. Now for the proof, I could go through the proof, okay, or I could not. And I'm going to say if you are interested, I'm looking at page 733 in your textbook. You're welcome to go through it on your own. The proof is actually rather short, but they make a interesting observation at the very beginning that just seems to come out of thin air. So you might end up scratching your head for a little bit, but I encourage you to look at that page in your textbook and just kind of review the solution, because it is something that could appear on homework, for example. So be aware of that.